everyone. I hope you all are safe in the current pandemic situation. And I'm Chintamani Pai, co-founder of Space Geeks. I welcome you on behalf of Space Geeks. And as we know that we are having a very awesome celestial event of shadows, which is coming on 21st of June, which is nothing but Annular Solar Eclipse. And as you know, the Annular Solar Eclipse is a great opportunity for enthusiasts, amateurs, and researchers to discover more about Sun, Earth, our atmosphere, space weather. And in all these aspects, we thought let us have some webinar in which we will try to give whatever best we can in this virtual session. And here I am to start this talk officially to inaugurate. So let me talk something about Space Geeks Mumbai. So Space Geeks Mumbai was started by myself, Chintamani Pai. Then we already have Dr. Ankush Bhaskar, who is joining us from NASA, GFSC. And we have today's our speaker, who is also our co-founder, Dr. Virendra Yadav. He is working at IIT Roorkee in the field of atmospheric physics. Ankush works in the field of space weather, and I work in the field of photonics and magnetism. We also have experts who are working with Space Geeks. We have Dr. Vaibhav Raut, who works in the field of high energy physics. And we also have experts along with us today, Hari, then Vishnu, then Rahul and Nilay, who are working with Space Geeks in capacity. So with that, I will give brief introduction to our speaker today, Dr. Virendra Yadav. So Dr. Virendra Yadav is an expert who is working in the field of atmospheric physics. Currently, as I said, he is working as Postdoctoral Fellow at IIT Roorkee. So his main research area is in the field of ionosphere. He did his BSc from Royal College, Mira Road, followed by MSc in physics from University of Mumbai, and later on PhD by Indian Institute of Geomagnetism in the field of ionosphere. Then he was research associate at IIG, and at present, of course, he's at Roorkee. He has 11 research papers in internationally peer-reviewed journals, and he has presented papers in various national and international conferences and workshops. He also got a first award in recent workshop held in Taiwan in the field of ionospheric physics. And of course, as a part of Space Geeks, as a co-founder, he frequently does science outreach activities like stargazing sessions, public talks, and teaching astronomy courses. And he himself is an expert in observational astronomy. And that is why we thought today to give you some aspects of the annular solar eclipse, which is going to happen on 21st of June. And I'm sure that whoever is in the belt of annular solar eclipse will have an opportunity to view this great celestial phenomenon. And with that, I invite Dr. Virendra to give a talk on annular solar eclipse. So let's welcome our speaker and let's start.
Now, this June 21st, 2020 is going to be an annular solar eclipse. So in this presentation, I'll be introducing some basic concepts about the eclipse and what you should do to observe it, and what kind of just a very brief snapshot on what kind of science can be done during various solar eclipses, or people have been doing during various solar eclipses. So this event is just going to be there in 2 days. So at Space Geeks, me and my friends, we thought why not have such a webinar where we could explain some of the basic things about solar eclipse or the annular solar eclipse. Okay, so before yeah, let us start with the presentation. Yeah. So before we go ahead with rest of the material, I just wanted to clarify a couple of terminologies beforehand. That what is the difference between an occultation, transit, and an eclipse? So now this is all from our point of view here on Earth. So for us, Sun and Moon are very large bodies. Their angular size is quite large when we see from here, as compared to say other stars or planets. So the first one over here is an example of the first one over here is an example of what is known as occultation. So here you have moon going in front of a star. So when the moon will be moving in the sky, it will obscure this star for a short while till the time the moon moves in front of the star, and maybe after say a few minutes or so, you'll be able to see the star again. So this is known as occultation. Okay. On the other hand of occultation, you have what is known as transit, where there is a small body moving in front of a large body. So here you have Venus passing through in front of the sun. So this is the sun, and this small black circle that you are seeing over here, this is Venus as seen from the Earth. So this is known as Venus transit. So in occultation, you have a large body moving in front of a small body as seen from the Earth, and in transit, you have a small body moving in front of a large body. Now, when the apparent size of the two bodies are nearly similar, that is known as eclipse. So this is an example of a solar eclipse where the moon is passing in front of the sun. Okay. So basically, an eclipse is a game of shadow, and both solar and lunar eclipses are nothing but game of shadows. So this picture that we have over here, I must tell you that this is not to the scale. This is just a representation. The actual size of the sun and the distances involved are very, very large as compared to the size of the moon or the earth. Okay. So here you have sun. This is the earth. And if the moon is present in between the sun and earth in a straight, so the shadow of moon will fall on the earth. And if you happen to be within that shadow, you will see that the sun is getting covered by the moon. So that's how a solar eclipse occurs. On the other hand, if the earth is in between the sun and the moon, then the shadow of the earth passes and completely covers the moon. So in that case, you will see that the shadow of the earth is falling on the moon. So that is known as the lunar eclipse. Okay. Another point, it should be noted that you can see here that this is the similar geometry of a new moon, what is known as Amavasya, where the moon is in between the sun and the earth. And similarly, this one, sun, earth, and moon, this is the geometry of a full moon. Okay, known as. So that's why a solar eclipse can happen only on a new moon day. A lunar eclipse can happen only on a full moon day. But all new moons are not solar eclipses. Similarly, all full moons are not lunar eclipses. This is obvious, right? Because we see that the eclipse is a much more rarer event, and we have full moons and new moons every 14 or 15 days. So why is it so? For that, we'll have to just quickly understand the phases of the moon. So here you have sunlight, then is the orbit of the moon, or rather the positions, various positions of the moon. So you can see that always the portion which is facing the sunlight is lit. Okay, so here you have daytime on the earth, here you have nighttime, and this is the lit portion of the moon, and this is the dark portion. So when you are seeing from the earth, you will see only the dark portion, and that's why it is the new moon. Similarly, this one and this one, when you will see from the earth, you will see that half portion, this lower half, is lit, and since we see half of that, that is quarter, and the opposite of that is the third quarter. So in reality, at each phase, half of the moon is lit, the one which is facing the sunlight. Okay, but depending upon what portion we are able to see, the different names have been given. So new moon, then you have increasing crescent, which is known as waxing phase. In the first quarter, the declination phase, and and this one is the full moon, and then again you have the waning phase, ultimately back to new moon. So these are the phases. Okay. Now, so although here I am giving the example of full moon, but a similar picture is present even during a new moon. So although we see that during the full moon, the earth is in between the sun and the moon, but they are not actually in a very straight line. They are not in a perfect straight line. Is actually slightly away. There is a very small angle. Again, please note that this picture is not to the scale. These distances are extremely, extremely large. Okay, this is a exaggerated picture just to explain the geometry. So due to this slight deviation from a perfect straight line geometry, during the full moon, you see this lit portion without the shadow of the earth falling on that. Okay. Similarly, on the new moon time, moon will be on this side, but not in a perfect straight line with the sun. It will be slightly further away, and that's why we will not be able to see an eclipse during that time, and neither will see the moon. So that is known as the new moon. Okay, but why does it happen? So the answer to that lies in the fact that the orbit of the moon is not the same as the orbit of the earth around sun. Okay, so what does it mean? So here, this blue line that you see, it represents the orbital plane of the earth, or the plane in which the earth moves around the sun. Okay, whereas the red line that you see here, it represents the orbital plane of the moon around the earth. So they are at an angle, they are not perfectly in the same plane. There is a small angle of 5.1 degrees. Okay, you can just forget the rest of the stuff. We just need to focus on this. So what happens because of this tilt? Yeah, so this is another example which will probably make it more clear. So because of this tilt, sometimes moon is above the earth's orbit, and sometimes the moon is below orbit. Okay, it's not in the perfect straight line. So for example, if the sun is over here and moon is over here, okay, at an angle in its orbit and not over here, so because of that, the shadow of the moon will miss the earth. Okay, and similarly, in this case, in the full moon phase, the sunlight will fall on the earth, and the shadow of the earth will miss the moon. Okay, And due to this difference in the orbital planes of the Earth and Moon, they intersect at two different points, okay, which are known as nodes. So this yellow line that you see is the apparent path of the Sun, or the actual path of the Earth around the Sun. Okay, so they are basically the same thing. And the gray line that you see here, this orbit is Moon's orbit around the Earth. You can see at some duration it is above the Earth's orbital plane, and for some duration it is below the Earth's orbital plane. So naturally, at 2 points, it will be intersecting. So the point at which it goes below the Earth's orbital plane, that is known as descending node, and the point where it goes above the Earth's orbital plane, that is known as ascending node. Okay, and only when the Moon is situated very close to these ascending or descending nodes, as well as the Sun's position is also in that direction, only in that case the shadow of the Earth will fall on the Moon, or the Moon will be able to come in a straight line between the Sun and the Earth. As a result, you'll have either a lunar eclipse or a solar eclipse. And in fact, these two nodes are the points which were known as Rahu and Ketu in ancient Indian astronomy. So Rahu and Ketu, although like at for general people or common people at that time, they were known as monsters who were eating the sun. But essentially, Rahu and Ketu are nothing but these ascending and descending nodes, where if the Moon is present, then there is a possibility of a lunar or a solar eclipse. So that was one factor why you don't have eclipses on every new moon or every full moon day. The next is why we are having an annular eclipse. So to understand that, we need to see how the orbit of the Moon is around the Sun. Around the Earth. So it's not a circular orbit; it's an elliptical orbit, which means that the nearest point of the Moon from the Earth, which is known as perigee, it's much more closer as compared to the farthest point in its orbit, which is known as. So that means when the Moon is over here, Moon is much closer to the Earth as compared to when the Moon is at this point. So what does happen because of that? Yeah. So if you have a full moon when the Moon is at perigee, so the apparent size of the Moon is larger as compared to a full moon when the full moon is at the apogee. Okay, so here you can see this lunar perigee and apogee is mentioned, and the numbers that you find in brackets over here, these are the apparent angular diameter of the Moon. Okay, in arc minutes. Sorry, in arc seconds. So it's 33.5 arc seconds, so nearly just over half a degree, and this is just slightly lesser than half a degree. Okay, and this is the perigee point. The distance is about 3,56,000 kilometers. And this is apogee point, where distance is about 4,06,000 kilometers. And in fact, when you have the full moon at the perigee point, that is known as the supermoon, where the apparent size of the moon is about 12% larger. Okay. Now, so if you have a condition where the Moon is in between the Sun and the Earth in perfect straight line, so an eclipse can happen. But as I showed earlier, that the orbit of the Moon is an elliptical orbit. It's not a perfectly circular orbit. So it means that sometimes the Moon will be closer to the Earth, and then sometimes Moon will be much farther away. Okay. So because of that, what will happen? The shadow which is falling on the Earth will not be the same at each time. Okay, so when the moon is closer to the earth, that time the shadow will be larger. Okay, at that time you can have a total solar eclipse where the apparent size of the moon will be slightly larger than the apparent size of the sun. So here you can see that this yellow dotted line, it shows the apparent size of the sun. Whereas when the moon is closer to the apogee position and it's a perfect straight line configuration, then you can have what is known as an annular eclipse. So this yellow part that you see over here around the moon, that is the sun. So in this case, the size of the moon is smaller as compared to the size of the sun. Okay. And why annular? So annulus basically means ring in Latin, and that's why it's known as annular eclipse. And suppose when the moon moves away from this central position slightly, in that case, the shadow will miss the earth. Okay, and some partial shadow will fall on which is known as partial eclipse, and in that case, you will see such a configuration. Okay. So, as I explained earlier, depending upon the distance of the moon from the earth, you have different shadows. So, the darker shadow which is there, that is known as umbra. It's a Latin word for shadow. And then there is a lighter shadow around the umbra, that is known as penumbra. So, if you are over here on the earth in the penumbra, over here or over here, you will see a partial eclipse. And suppose the moon was much closer, so that the earth was somewhere over here, that is in the umbra, there you would have seen a total solar eclipse. But if the moon is farther, like in this arrangement, then you will have something what is known as entumbra. And if you are there within that entumbra, you will see a lunar eclipse. I'm sorry, an annular eclipse. If you are here, you see an annular eclipse. I beg your pardon. So umbra, penumbra, and entumbra. So this is a three different types of shadows, and depending upon where you are, you will see a different phase of the eclipse on the same day. Now, as you can see here, the size or the distance that the penumbra is covering, it's much more larger as compared to, say, umbra or penumbra. So that's why the partial eclipse is seen for a much wider region, whereas the total or annular eclipse is seen in a very small, narrow belt. Okay. So again, to summarize this, so you have moon in between the sun and the earth over here. Now, suppose the earth is over here, so that it's very close to the moon. In that case, what will happen? The apparent size of the moon is larger. Okay. And because of when earth will pass through the shadow, so this is how you will see that the apparent size of the moon is slightly larger. Then where you will see that the shadow is touching for the first time, that is known as first contact. Then the second edge, that is known as second contact. And when it starts coming out of the shadow, that is known as third contact. And ultimately, the last point where the shadows touch, that is known as fourth contact. So in this case, you can see that the black circle representing the size of the moon is slightly larger than this yellow dotted line, which represents the size of the sun. Okay. And the ratio between the angular diameter of the two bodies, that is known as the magnitude. Okay. So magnitude larger than 1, it means the angular size of the moon is larger than the angular size of the sun. Okay. And in this situation, you will see a total eclipse when you are within the umbra. Okay. And special place where you are just exactly at this point where your the angular sizes of the two bodies exactly match. So in that case, also you will see a total solar eclipse, but the eclipse will last just for an instant. Okay, If you are over here, the eclipse will last for a few minutes. I'm just talking about the total phase. The sun will appear something like this. If you are over here, it will last just for a fraction of a second. Okay, but again the phase will be like this. Now suppose the moon is still farther away. That means the angular size of the moon will be smaller, and that's why the magnitude will be less than 1. And in that case, you will see a strip of the sun all around the moon like this. Okay, so this is the annular eclipse. And then if you are anywhere over in this shadow, in this zone, the blue one, then it will appear as a partial eclipse like this. Okay, so this is how your different eclipse can occur, whether total, partial, or annular. So as we know that the annular eclipse on June 21 is going to be visible in the northern part of India. So I have just shown you some portion of North India. Over here, you have New Delhi, and then here you have Dehradun. I am right now over here in Roorkee. Then here you have Ludhiana. Somewhere over here you have Amritsar. Then this is Shimla. So as you will move closer to the shadow, you will see that the partial eclipse is getting bigger and bigger. Okay, as you move towards this line. If you are very far away, even during the maximum phase, you will see a very small phase of the sun, which will be covered. But if you move closer to this shadow belt, then you will see a larger and larger portion of the sun is getting covered. And if you are within this central belt, you will see an annular eclipse. So you will see a very thin strip of the sun around the earth. As you can see, this is the greatest eclipse point, and this will happen at around 6:40 UT, which is the Greenwich Mean Time. So you have to add another 5.5 hours to that, and you can see that the magnitude of the eclipse is about 99.4%. Okay, I hope that you are able to see this because the numbers are very small. So this means that a very, very thin strip of the sun will be visible. Okay, and that's why, since the strip of the sun will be very thin, the duration is going to be just for a few seconds. Okay, so this is about 38 seconds. Okay, or at the maximum duration. If you are anywhere over here, so suppose if you move towards this red line, just some over here or somewhere over here, the annular eclipse will last only for a few seconds. Okay, like 1 or 2 seconds at the most. And right now I am over here in Roorkee. So for me, the eclipse is going to be a partial eclipse. Okay, day after tomorrow. But since I am very close to this line, it is just about, I think, around 15 to 20 kilometers from here. So for me, the magnitude of the eclipse is going to be about 98% or 0.98. So it's going to be very close to an annular eclipse, and I'm going to see a very, very thin crescent of the sun at one side during the maximum time. Okay. Now, unfortunately, due to this COVID pandemic situation, the travel is not possible anywhere. Otherwise, I was planning to go somewhere over here and then stream it from there. So, but we'll have to do it from here. On our channel, we'll be streaming it, and then you'll be able to see on our Facebook or YouTube channels. Okay. Now, this map is available for this eclipse, but even for this eclipse and for other eclipses, including solar eclipses and lunar eclipses, if you want to see the path of the shadow, okay, like from your place, how the eclipse will appear from your place, then you can go on this website, Xavier. It's a free website, and it essentially simulates the eclipse for your place and your time, okay, for any given eclipse. Now, yeah. So this is how the entire path is going to be, and this is the greatest eclipse point. And yeah, so here on this side, somewhere in Africa, the eclipse is going to be during sunrise, the starting time. Then over northern India, it's going to be there closer to the time. Then over here, it's going to be there in the afternoon, and then over here, it will be there during the moon set. Okay. Now, someone had just asked like how it will appear from your place. So you can see that this is the penumbral shadow. Okay, and this very small moving dot that you are seeing, that is the path of annularity. Okay, so I'll just play it once again. Yeah. So if you are anywhere in this shadow zone, you will see a partial eclipse. And if you are closer to this dot, you will see more and more portion of the sun is getting covered. So that means the partial eclipse is going to be larger and larger for you as you move closer and closer to this small dot. Okay, this is the path of the annularity, and if you are within that small central path, you will see that eclipse is going to be clear for you. Okay, I'll request all of you when you have time. So just go to this website of Xavier Jubier, or for example, another website called diamonddate.com, where you'll be able to see. You just have to enter your city or locate your city or place on the map, and then you'll be able to see the timings for your place, as well as how much area of the sun is going to be get covered during the eclipse. You'll be able to see that as well. Now, coming to how to see the eclipse. Now, before we cover how to see the eclipse, I should mention how not to see a solar eclipse. So you cannot have your normal glasses or goggles. You cannot use simple binoculars. You cannot use a normal telescope. You cannot use naked eyes or even camera, point at the sun and try to your eyes, because if you do that, your eyes are going to get damaged. Even when there is a thin crescent of the sun visible, sun is extremely bright, and it is continuously giving out very intense radiation, so it can damage your eyes and retina. So we urge you not to use any of these methods to see an solar eclipse, either on Sunday or anytime in future. So what is the safe method to see a solar eclipse? So before I come to that, this is how the eclipse will appear. Sorry, this is how the eclipse will appear day after tomorrow. This is an annular solar eclipse that we had captured on 15 January 2010 from Rameshwaram. So here you can see that this white portion is the sun, and this is the moon. And for day after tomorrow's eclipse, this white part is going to be even thinner, because the apparent size of the moon is going to be bigger than. Okay, so this annular eclipse lasted for nearly 10 minutes, but the one on 21st June, that is day after tomorrow, that is going to last only for 38 seconds, even at the maximum duration. Okay, so what should you do? So these are known as solar eclipse goggle or solar eclipse glasses. You should use these. Okay, these are a special kind of filters. These are specially made thin aluminum sheets, which reduces the intensity of the sun by a factor of more than 1,000,000 times. Okay, you cannot use this to see anything else. You'll be able to see very bright source like sun. Okay, so it reduces the intensity, and then we can use these to look at the solar eclipse. Or you can use what is known as a solar telescope. Now these are very special instruments which are specially used only to observe the sun. Okay, and these are very expensive instruments. So generally, only research institutes have them, or universities. If you don't have that, if you have a normal telescope, you can put special filters on top of the tube, okay, which will reduce the intensity of the sun, and in that case, you can safely look at the sun. But please keep in mind, you have to put this filter on top. If you don't put this filter and try to look at the sun directly, even during a solar eclipse, your eyes can get damaged completely and permanently within a few seconds. So please never ever do that. Okay, these are special kind of filters made up of very thick glass with special treatments, and or very thin, specially made aluminum sheets. Okay. Now, if you don't have those, then what else can you do? So there is this projection method, and if you have a telescope, you can attach this kind of cardboard sheet, okay, so that there is a small shadow zone or dark zone behind the telescope, and over here you can see that this is the sun. Okay, so this is a projection of the sun. There is no filter attached over here, and if you have a small telescope, you can try this method. But if there is a big telescope, it's better not to do that, because the heat is going to be too much for a larger telescope, and the mirror can get damaged, or the lenses can get damaged. But if it's a very small telescope, then yes, this can be done. But please, if you are doing or using this projection method, then don't ever try to see from your own eyes over here. Okay, so this is the projection of the sun. But what if you have a telescope? You can use this pinhole camera projection method. Okay, so for that, you can have a cardboard with a very small hole in between, and then you can have a screen behind that, so that the eclipse will be projected. Okay, so you can see that the moon is partially covering the sun, and it will appear like this, like a crescent. And as and when the moon moves closer and closer, completely covers the sun, and then you will see a total or annular eclipse, whatever is the case. Now, in this case, the region around this may not be sufficiently dark. Okay, so the contrast may not be very good to see it outside. So you can prepare a special kind of box arrangement like this, where you attach, you make a small cut, and on that cut you attach those aluminum foils, like you get for preserving these food items to hot. So you use that kind of thin aluminum foil, and you can just make a small hole in that from a pin. Okay, and then at the bottom of the cardboard, you can make a small cut, so that you can insert your head from here. But you should not be covering this ray path. Okay, and then over here you can have a white sheet on which you can have the projection, and will be able to see the eclipse. So this is a sort of indirect method to safely view an eclipse. Now, in addition to all this, so till now, whatever I have told you, these have been the observations from the ground. Now, there have been instances where people have observed solar eclipses even from flights. Okay, but again, you will need these kind of glasses, eclipse goggles, to see the eclipse. And such have successfully chased the shadow of the eclipse, in which, so for example, this was an eclipse in 1955, where on the ground the totality duration was for about 7 minutes, and when they chased the shadow in a fighter jet, they were able to observe the totality for longer duration. And with even faster aircrafts, this can be done for even larger duration. Okay. And even in India during 1995, such an exercise was carried out where one fighter pilot of Indian Air Force, he flew on a fighter jet, and some measurements were carried out for the Department of Science and Technology Institutes. So this, why a fighter jet? Because the speeds are so high that you need a very high velocity fighter. You can see that here the speed was something like 2.5 times the speed of sound. So you need very high velocity aircraft to chase the shadow of the moon because it moves very, very fast. Uh, Even we had sort of seen the eclipse from an aircraft. I'm using the word sort of because we did not actually chase the shadow because we were not interested in chasing the shadow. However, we were interested in recording the eclipse. So this was an annular eclipse last year, and we carried out this exercise from Mumbai, where the eclipse was partial, and it was expected that it's going to be a cloudy weather. So, along with a private aviation company, Space Geeks had organized this flight where we had called a few people from space backgrounds, people working in planetarium, people working in universities, in the field of astrobiology, space policymakers, and writers. And, we had recorded this eclipse on board the small aircraft. So this was last year. Now, so till now, this has been everything like at a popular level, or if you're just interested as a hobby, or just want to see the eclipse, then what you need to do. But an eclipse is not only good for just hobby viewing. There have been science experiments also carried out during various eclipses. But generally, this happens mainly during uh, total solar eclipse. Annular eclipses do not have that kind of directly different kind of imaging that I am going to talk about over here. So, in fact, helium was discovered first on the sun. This was because of the measurements carried out on August 18, 1868 eclipse, where this French astronomer Jules he came to India and he observed this spectrum of the sun. And during the eclipse, he observed some lines, and one of the lines was not known earlier, particularly this line that you see over here. And at that time, it was understood that we thought that it is sodium. So here you can see the spectrum of sodium. This is the spectrum of helium. So he initially thought that this line actually belongs to sodium. But later on, in the same year, uh, there were two other guys, English astronomer, and then this chemist. So they showed that it's actually a different line. It's not a sodium line. Okay, and so this was a new element which was discovered, and they named it as per the Greek name of the sun, which is Helios. So that's how the name helium came. And helium is probably the only element, and the first element which was first discovered on the sun. Earth. Okay, and yeah. So couple of more just slides. So Einstein and Eddington. So Einstein had given his general theory of relativity, where he had said that extremely heavy mass objects like stars and planets, they bend the space-time. So at that time, people did not take it that seriously. But there was this English astronomer, Arthur Eddington. He thought that this theory can be proved or disproved, or rather disproved, during the solar eclipse that was going to take place in 1919 in Africa. So that's what he did. He took the photograph of the eclipse. So it was a total solar eclipse, because of which there were few bright stars visible around the sun in the night sky. And then what he did, he measured the position of those stars. So the stars which were far away from the sun, when the eclipse happened, and when he took the another image when the sun was not in the same position, an image of the same part of the sky. So the faraway stars were at the same position, but the nearby stars were actually shifted. If you can see this one, there is a shift. Okay, so why does that happen? That is happening because of gravitational lensing, where the path of the light bends around a heavy object like a planet or a star. Okay, and because of this bending, we feel that the apparent position of the star is somewhere over here. So this is an exaggerated picture again, which is used just to show your shift in the position of the stars due to the presence of the sun. So this was actually heard during the total solar eclipse of 1990, and Einstein was proved right. Now, in recent times, so although everyone is dreading by hearing this word right now, corona, but I'm not talking about the virus over here. I'm talking about the atmosphere of the sun. So during a total solar eclipse, this is a picture captured by our team member Ankush when the eclipse happened 2 years ago from USA. So this diffused glow that you are seeing around the sun, it's actually the atmosphere of the sun. And this atmosphere is known as corona. And it is only possible to see the corona when there is a total solar eclipse, when you are at ground level or closer to the surface of the earth. And this corona can be seen even with the naked eye. So only when sun gets covered during a total solar eclipse, at that time, so for a short duration, you can remove your glasses or eclipse glasses, or you can directly look at the sky, and then you'll be able to see this corona. And you'll see that the entire sky is very, very dark. You'll be able to see the bright stars. It's actually a very, very exhilarating experience. I urge you to, if you have a chance, go and observe a total solar eclipse at least once in your lifetime. So, unfortunately, for the next 100 years, there is no total solar eclipse from India. There is one, I think, in 2030 or 40, somewhere around that, but it's going to be visible only from the extreme north part of India, somewhere closer to Siachen. So for other total solar eclipses, you'll have to go somewhere out of India, probably in the near future. So yeah, so at these times, whenever a total solar eclipse happens, so there are modern instruments or photographs which try to capture this corona and the kind of changes that are there in this corona. And we try to study the atmosphere of the sun. And this is not only observational studies, there have been modeling studies as well, where scientists have modeled the atmosphere of the sun for various purposes. And if you see this slide and this slide, you can see that some of the structures are similar, like this kind of glows that you see. So actually, scientists can model a corona. In fact, this is a modeling of the similar eclipse, and this has been carried out here. These kind of studies are now carried out even in India. So there are people at institutes in Kolkata who are doing this kind of modeling studies. So that's all I have for you in this presentation. So this was to understand what basically it's a great celestial and natural experiment. It's a great time and great experiment, natural experiment that's happening. And I urge you to go out. If you have filters with you, then you can observe the solar eclipse. Keep in mind, there are a lot of myths around as far as eclipses are concerned, that you should not go out, or you should not eat, you should not drink during a solar eclipse, or pregnant females should not be looking at an eclipse. But all these are myths. In fact, whenever we arrange an eclipse viewing, we try to even eat during at that time. We even travel during at that time, and you have seen that people have traveled even in flights during an eclipse. So there is no harm in observing a total solar eclipse if you have the protective glasses or filters. And there are other myths as well, where they say that you can keep water in, you can observe the eclipse from that, but even that is not safe. You should have either filters, or you should have either solar telescope, or you should have a pinhole projection method, or a telescopic projection method, by which you should see the eclipse. Okay, so that's all I have for you in this presentation. So I guess we'll be taking
Bhandela
the
Bhandar.
presentations.
Okay, thank you, Virendra, for wonderful talk. We have some questions. Ankush, have you noted down, or shall I?
If you have also, you can go ahead, but I also noted down.
So, okay, then you start with the question. Yeah.
Okay, so we should thank you, Virendra, for a informative talk, and I hope everybody learned something about eclipse and how to observe it also. So let's go ahead with questions. We have a number of questions. Okay, and I have noted some. Virendra, sorry, Vaibhav, you can keep track of remaining questions now, new whatever coming. I will just start with.
Yes.
So let's go with the first question. Sandeep asked the question. Please explain Krishna Paksha and Shukla Paksha. Meera, can you talk on that?
So yeah. So let us go back to the presentation. Ankush, can you just tell me whether you can see the slides? The
Yes.
slideshow, is it still visible?
Yeah. You are
Okay.
still present.
Yeah. So yes, as I told you that these are various phases of the moon as it moves around its orbit. So this is the new moon or Amavasya phase, where the sunlit portion is facing the sun and only the dark portion is facing the earth. On the opposite side, you have full moon or Purnima, where the sunlit portion is facing the earth as well as the sun. Okay. So when you are over here, you cannot see any portion of the moon. When the crescent starts increasing, okay, what is known as waxing phase, you will see a very small portion of the lit portion first. Like they say, na, Eid ka chand. You may have seen that very thin crescent. So that is the initial phase just after one day of a new moon. And then it starts increasing. Okay. So this increasing lit portion is visible from the earth. So if you are over here, you will see this half portion, something like this. You will see the moon like this. If you are over here, you will see the moon like this. Similarly, if you are over here, if the moon is in this phase, you will see it like this. So a large portion of the moon lit portion will be visible from the earth. Whereas if the moon is in this position, you will see the complete lit portion. Okay. So from here to here, we will see a larger and larger portion or sunlit portion of the moon. Okay. So this waxing phase or increasing phase is known as Shukla. Okay.
Yeah.
After the full moon, when it starts waning or reducing, then again it will become, the sunlit portion will become smaller and smaller when as seen from the earth. Okay. In this phase again you'll see a very small crescent, and then back to over here. So this decreasing phase, it is known as Krishna Paksha. Krishna means black. So the moon is getting darker and darker, and that's why this is known as Krishna Paksha, and this is known as Shukla Paksha.
Okay, so there are some related questions from Sagar Shinde and again Sagar Shinde, and then there's Sandeep. So this Sagar Shinde asked about every year is the lunar eclipse seen at the same position? Then which
No.
wait, and then another related question: which factor determines the date and position at which the annular solar eclipse is seen? And then another related question is: how does this eclipse calculation done?
Okay, these are very important questions, and if I have answered in detail, it is going to take at least a few lectures only for these questions. So I'll just briefly
Yes.
answer those. So what happens
मला ये
is
option
that
नहीं है.
you have seen that this is the
Please mute.
orbit of the moon around the Earth. Okay, I'll probably use some other slide.
हे सोपं आहे.
Yeah,
Oops.
I will
कौन है
use
यार?
this one.
Find.
Yeah, so I will use this slide. So as I showed earlier, that this is the orbit of the moon. Okay, and when the moon is near one of the nodes, either the ascending node or the descending node, and the sun is visible in the same direction, only then moon can come in between the sun and earth, or the earth can come in between the sun and the moon, and that's how an eclipse is. Now there are different periods involved.
Hello.
So sun completes a complete the moon completes one complete 360 degree rotations in about 27 days or so. But the new moon to new moon period, that is one lunar month, or new moon to new moon period, or full moon to full moon period, one lunar month is about 29 point some days. Then in addition to these, the ascending node, the position of these ascending nodes and descending nodes, it's not fixed. The entire orbit is rotating. So slowly, the intersection point that you see over here, it slowly and slowly shifts. So after some time, it will be over here, and the other node will be over here. Then after some time, the descending node will be here, the ascending node will be here. Then again, it will shift. So this ascending and descending nodes also shift. The entire shift. So whenever there is an eclipse, so for example, now 31st June, now it's going to be one solar eclipse. So the in 15 days before, 14 or 15 days before an eclipse, and 15 or 14 days after an eclipse, the moon doesn't shift too far away from that intersection point. Okay, so that's why always you will find eclipses occur in a triplet. So there will be one lunar eclipse, then a solar eclipse, then again a lunar eclipse, or there will be a solar eclipse, then a lunar eclipse, then again a solar eclipse. So we have a solar eclipse on June 21st. The previous full moon, there was a lunar eclipse. And then again on the next full moon, I think somewhere on 5th July, again it's going to be a lunar eclipse. So like consecutively, there is a window of nearly a month in which three eclipses can occur, two of one type and one of the other type, solar and lunar. So, but this is fixed 1 month. Other than that, there are different kind of periods. As I told, that there is a shifting of these nodes. So when the moon moves too much away from the nodes, the eclipse will not occur. So the moon has to come back to one of the nodes for another eclipse to occur. But whenever suppose the moon comes back to that node, by that time the Earth also has rotated. So some other portion of the Earth will be facing the shadow of the moon. So that's why, if you remember, this eclipse is going to be visible from northern India, but the eclipse which occurred in December, that was visible from southern India. We were sort of lucky that within 6 months we were able to see two different eclipses in the same country. Within India itself, we were able to see, but many times, like the other eclipse will be totally somewhere else. So there are many different kind of periodicities, and it's really difficult to explain in this particular lectures. But there is something known as arrow cycles. There is a cycle of such precisions of the orbits, and because of that, the ascending node and descending node also shifts. And at different places, you can have different eclipses. So there is a whole calculation behind that. But as I said, that it's going to take at least a few series of lectures to answer those in detail. I think I'll stop with that question. Ankush or Chinta, can we have the next question? Or Vaibhav?
Okay. Virendra, so
Yeah.
next question is one is how much can it be seen from the Kolkata? That means the Prithvis want to ask this.
Yeah, so as I said, that if you go to
Yeah, so now there is one more app I just want to tell you about. There is an Eclipse 2.0. There is a simple mobile app you can install, and you can basically have an eclipse simulation as well on your mobile phone.
Yeah, I think
So
it
we
will
can-
use your
we
GPS
can,
location.
Right.
Then
So we can send them these links by email.
Yes.
So whoever has
by
participated,
emails, yes.
we will be sending you by email. So you can simulate these conditions from your locations.
Yes. Then there is one more
This is
question
another
from
website.
there is one more question. I have a sun filter to be fitted on Orion telescope. Can I see the eclipse through this filter?
If it is a solar filter, the one which is like a very thin aluminum sheet, and the sheet does not have any holes or tear in that, then yes, you can attach it on top of that telescope, such that no direct sunlight is falling on the mirror or lens of the telescope. All the light is falling only on the filter. Only in that
Yes.
case you can use the
Yes.
telescope and
Yes.
look
So
from your eyes. But without the
so
filter, please do not look at this.
Okay, so one has to
Next
take
question.
precautions whether there are no scratches or anything on the filter. That is what
Yes.
you're saying. So make
Because
sure
even
that
a
you're
very
using
small
the
dot or
yeah.
tear can damage your eyes.
So make sure you are using the good quality filter without any scratches or holes in it. Then there is one question is from the Sagar Shinde is, does it have any implications on pregnant women?
No, so these are just myths, as I said earlier.
Yeah.
Because see,
Okay.
at earlier times it was not known like what is happening during an eclipse where the sun is
Yeah,
going. There were different kind of myths.
Yeah, and then this related question from Sunita: why people are afraid
Yeah.
to go out during the eclipses?
No, as I said, that it is only myths which have been perpetuated from from very
Yeah.
old times. People
Yes.
did
Yes.
not know where the sun is going. There were different kind of beliefs, like some animal or monster is
Yeah.
eating away the
Okay.
sun,
Okay.
and these
Okay.
were just myths. At present,
Yeah.
like you have people, scientists
Okay.
going out for various
Yeah.
studies.
There
They
is
have
one. Yeah.
different kind of
Yeah.
astrotourisms happening, so
Yeah.
it's perfectly safe to go out and observe it.
There is one question from Ayush Jede. What is equinox? He's asking what is equinox.
Well, equinox is when the day and night duration the same. So that happens on 21st of March and 22nd September, like within few hours of that particular time, depending upon the orbits. So that at that time, the day night is of equal duration everywhere on the Earth. So that
Yeah.
is known as equinox. Tomorrow
Okay.
we are going
They.
to, sorry, day after tomorrow we are going to have what is known as the summer solstice. That means the day duration is the largest in the northern hemisphere, and it is the smallest in the southern hemisphere. And the winter solstice is going to be on 22nd December, where in the northern hemisphere you have shortest day and the longest night.
Okay, so there is one question from Pallavi Sontakke, that is it going to affect the corona like in December it has started, because there was one eclipse was in December and it is supposed to end by this eclipse. That is what she must have read in the news.
Oh, okay. I think by corona she means the coronavirus.
Oh yeah,
So
she,
it
I get,
doesn't have, yeah, it doesn't have any implication on coronavirus. See, because by December, like a lot of cases had come up already, and by then it was known that okay, that there is some sort of pandemic going on. But there have been reports of the disease and the virus much before December. There have been various reports where they say that cases were coming up even last year in August and September, and so on. So this coronavirus is not going to be affected by this eclipse at all. It is a totally different thing. And in fact, if you see that number of cases are so large that it is probably going to take months and years to subsidize. Okay, with proper precaution like maintaining social distancing, maintaining the hygiene, frequently washing your hands, wearing masks, and so on. So the solar eclipse does not have any bearing on the coronavirus.
Rohit Tiwari asked about other than religious beliefs, what are the scientific significance to learn lunar or solar eclipses?
So I had covered very few of those in my slide. So yeah, one was there were some past studies where where they
And
discovered helium in the atmosphere of the sun. And then later on also, I did not mention in this slide, but there was another case where very hot temperature iron was discovered in the atmosphere of the sun. And then the evidence of general theory of relativity, the bending of light was the evidence for that was found in 1919 total solar eclipse from Africa. Then at present, various kind of modeling studies and as well as spectroscopic studies are going on where they monitor the variations in corona. In fact, the slide that I showed, the one of 15th January 2010 annular solar eclipse, which we had observed from Rameshwaram. So all of us, our Space Geeks members, at that time we were in universities during our masters, and who had completed his PhD. So all of us were there in Mumbai University, and from there we had gone to Rameshwaram, and we had carried a lot of instruments with us to measure different kind of cosmic rays and radiations that are coming from different kinds of sources in the universe. And then as they enter the atmosphere, they sort of form a shower which can be detected by these instruments. Now, because of a solar eclipse, there is a contraction in the atmosphere because it cools down, and then there are certain variations in that which can be measured.
Yes. So one of our co-founder currently doing a postdoctoral fellowship, Ankush Bhaskar in NASA, he experienced this 2017 eclipse, I think. So can you just talk briefly about your experience, Ankush?
About total eclipse, so that's a fantastic experience to have. You cannot explain actually. You can see the image, and image doesn't do the justice with naked eye and through telescope with a proper precaution. Can you see there is a loop-like structure around?
Ankush is talking about this one.
Yeah. This is called a prominence. So sun is not a very spherical ball without anything on that. So it's very active object, and you can see that's a prominence we call. It's a plasma or a gas from the sun, which gets thrown out of its surface. And this is very big, like many Earths you can fit in that size. Okay, so these dimensions are very large, and you could see that during eclipse. So I will say I don't want to describe on that. If you get a chance to observe total solar eclipse, just watch it and witness, and you will understand what I'm saying. You cannot explain that in terms of words. It's just a moment and lifetime.
Words cannot describe it.
Yeah.
Yes, and unfortunately, we are not able to travel, or are not allowed to travel to the North India to witness this eclipse, which is quite close to what what view we have for a total eclipse, right?
Yeah, it's going to be an annular eclipse, but a very thin strip of the sun is going to be visible all around the sun. So it's going to be somewhat like this. Uh,
Hmm.
yeah, somewhat
Yes.
like this. But instead of such a broad strip of the sun, a very thin strip is going to be visible.
Okay.
Like this.
Uh, okay. And there is one more question from
Yeah.
Prajakta Bhide that I would like to know in what all areas any eclipse adds to the existing scientific knowledge.
So I think we already covered some of those, like atmospheric studies, space weather studies. Then there is something in the atmospheric layer known as ionosphere, where there is a lot of plasma content in the atmospheric layer between 50 kilometers to 1,000 kilometers. So, and that ion production is because of the sun. So, when during an eclipse, it gets covered, the ion production reduces, the ionospheric content, the plasma density reduces, and there are different kind of space physics effects that can be studied or investigated based on that. And plus,
We,
you can
Uh,
also do the atmospheric study of the sun, the corona. You can study that as well.
Veera, can
yeah,
I add something?
yeah.
See,
One point even I want to add. Yeah.
Yeah, yeah.
So the effects what we have seen. So there is one the scientific aspect of that we have seen. I mean, as a part of space weather. The other interesting domain what people are interested in it is to understand the biological effects of the eclipses. Like typically, since as you know there is sudden darkness you experience, that there is sudden temperature difference, humidity difference, because ultimately these weather effects are generated due to the shadow. The shadow of the moon on earth. So what people are interested, typically zoologists, is that since animal they are actually tuned to regular cycle of day and light, day and night. So if there is suddenly a shadow comes, how they typically, animals, birds, how they respond, how plants respond. People have even studied typical photosynthesis or even growth of microbes also, how whether that time window is even enough to cause any substantial changes. So there are these kind of studies available. So people have done that.
There is one question from Nitina that if someone see eclipse and their eyes get affected, what should we do as a first aid? It will take some time to reach doctor. What can we do as a first aid? And then another related question, I think from Sagar Shinde, why are sun rays during the annular eclipse harmful to our eyes than any other days?
Okay, so I'll answer the second question first. Is that see, sun is extremely bright. So even if a very small part of the sun is still visible, like in an annular eclipse, so even if a very thin strip is visible, it is extremely bright. So our eyes are not used to or adapted to such kind of brightnesses. It can damage the retina. Okay, so that's why it is advised that you should use proper protective equipments like filters and solar telescopes, etc., to observe the sun. Now, if you try to, like, when there is a no eclipse and directly sun is present, and if you try to look at the sun directly, it's really difficult because it's extremely bright, and immediately you move away your eyes. But what happens that
Hmm.
during an eclipse, as a larger and larger portion of the sun is getting covered, we get this impression that probably since a very little portion of the sun is now visible, it might be safe to look at it. But no, it's
Hmm.
not so. So
Uh,
that's why you should not look at the sun. Only when it is a total solar eclipse and the sun has been completely covered and only the atmosphere of the sun is visible, only at that particular time you can observe the sun with your naked eyes. Because if you observe at any other time, then it may damage your eyes. So, like
Yeah.
by chance, if you are just you happen to look at the sun without any kind of protective equipment, the only thing that you can do is that close your eyes immediately and move your gaze away from there. You should not be looking at the sun directly at any instant before the totality, which is not going to be there in this eclipse. So, no, at no point of time during this eclipse, you should be looking at the sun directly from naked eyes.
There is one question, perhaps he has typed his name as in his computer name, Dell. The question is, can you please throw some light on Aryabhatta's description of eclipse, which is regarded as the ancient description regarding the cause and effect of eclipse?
Okay, so see, these are just uh, play of position of the moon and the earth. Any eclipse, whether it's a solar eclipse or a lunar eclipse. Now, depending upon, so if you can accurately predict the position, like where it's going to be located, then you will be able to predict when an eclipse is going to occur. So that's what people had done in ancient India, and not only in India, even in other places where they had predicted the occurrences of eclipses. And usually these predictions were not as accurate as the modern days, but with certain, I mean, as compared to at that time, we could, with decent amount of accuracy, you could predict that at so and so point of time in future an eclipse is going to occur. And in fact, in 1700s, Edmund Halley, who is famous for Halley comet, in 1700s, sometime he had predicted an eclipse, and his prediction was just 4 minutes off from the actual occurrence of the eclipse. And the path where he had predicted that the shadow is going to be visible from so and so place, that was missing the place just by some 20 or 30 kilometers. So similarly, even before that, we had some rough ideas about the period of the Earth around the Sun and the period of Moon around the Earth, but these were
Yeah.
not known to a very precise, decimal or lots of decimal places that we do in modern times. So the predictions
Okay.
at that time were not as accurate as we have in the last couple of decades or so.
There is one question from Dhanashri that
Yeah.
what is meant by Stellarium software?
Yeah, so Stellarium is one sort of simulation software where you can enter your position and you can enter the date and time, and it will show you how the entire sky is appearing. So if it is daytime, it will show you the positions of sun. And for the night times, it will show you the entire positions of all the stars, constellations, moon, and different kind of planets. So you can play around with the software. It's a free software available for Windows, Linux, as well as Mac. And on mobile, Stellarium, I think is not available, but there is an alternative known as Google Sky or Sky
Yeah.
Map, which you can install, and then you can just enable your location sharing, and based on your location and your mobile's time, it will
Okay.
show you what kind of
Okay.
stars and planets are
Okay.
visible in the
That's
night
fine.
sky. You can just
That's
point
fine.
it based on the gyroscope, and it will show
Okay.
you like what star or constellations you are looking
Okay.
at.
Okay.
Yeah.
There is a similar questions from Tejas, Durve and Pallavi that can you please explain Rahu and Ketu once again?
Okay, so yeah. So this slide, as I mentioned earlier, that the the yellow circle that you are seeing, this is the apparent orbit of the sun around Earth. So from the Earth, if we see the sun is following a particular path in the sky, okay, throughout the year. That is basically because the Earth is rotating around the sun throughout the year. And you have moon which is orbiting around the Earth. So these two orbits are not in same plane. That means they are not exactly like this. Okay, they are somewhat at an angle. So you can see that this gray circle, which is representing the plane of the moon's orbit around the Earth, it is intersecting the Earth's orbital plane, which is represented by this yellow circle. Okay.
Yeah.
And because they are at an angle, there are 2 points where they intersect. Okay. And these are known as ascending node and descending node. So at descending node, the moon's orbit or moon, it goes from above the Earth's orbital plane to below the Earth's orbital plane. And similarly, at the ascending node, it rises from below the Earth's orbit to above the Earth's orbit. So these
Yes.
intersection points, these were known as Rahu and Ketu. So in
Okay.
ancient Indian
I think-
astronomy,
yeah.
keep in mind I am talking about astronomy, not astrology. Okay. So in ancient Indian astronomy, these Rahu and Ketu, these were these ascending and descending nodes that whenever the moon was present near either of these nodes and the sun was also visible in the same direction. So at that time, you could have either a solar eclipse or a lunar eclipse.
Okay.
So yeah, that is
There is
known as
one.
Rahu and Ketu.
Yeah. There is one question. Can eclipse eclipse can affect an Earth's gravitational field or on acceleration due to gravity?
Okay. So see, gravity is because of the distance and mass of any particular object. Okay. So if you see this, okay, at this point, the sun and the moon are in the same direction, okay, on this side of the earth as compared to being, say, on this side. So gravity over here, gravitational pull because of the sun and the moon is in the same direction. Okay, so they will be pulling any object in this direction. So although this effect is not very strong as compared to the gravity of the earth itself, but the tides that you see are because of that. Okay. Similarly, when the moon is on this side, at that particular time also, you can have a gravitational pull on a body over here due to the moon, and that will be pulling that particular body on this side. So effectively, there will be a very small reduction in the gravity, okay, at this point, and when both the bodies are on this side. So, and in fact, that is the reason why you see tides in the ocean, seas, and the atmosphere, where the water or the atmosphere moves towards the moon. But this situation is not only strictly happening during. It doesn't only happen during an eclipse, because even during
Okay.
new moon and full moon,
Yeah.
the positions are nearly the same. They are not exactly in the same line, but the positions are nearly the same.
Okay.
So the gravity effect is nearly similar on
Okay.
a solar eclipse and on a new moon, and
Yeah.
nearly similar on a full moon and a lunar eclipse. Okay.
Okay.
The eclipses
Yeah.
themselves don't have any huge significant difference.
Okay. The one. Okay. So then one. Just I want to highlight the event which we had about viewing an eclipse from an aircraft. So
Yeah.
Chintamani Pai have conceptualized that particular event, and so can you, Chintamani, throw some light on the challenges chasing the shadow through the aircraft?
Okay, so guys, yeah. So since Vaibhav has told me to talk about our previous event, yeah, so let me talk it very brief. So the whole idea we had, okay, there were 3 aspects. One is promoting astrotourism, because country like India, we have a lot of scope for tourism, and if we combine it with astronomical events, we generate a lot of opportunities. The another aspect was through such astrotourism event, we can create awareness about space science and space technology. And the very third aspect, which I am highly interested in, is actually I was actually interested to chase the shadow of the moon by an aircraft. So in fact, myself, Vaibhav and Hari, we were actually involved in the calculations, and we had even simulated the scenario till an extent that if we could able to actually chase the shadow, but somehow of course, such kind of experiments are costly, and we of course require funding. So we couldn't chase the shadow. Then what we did, the another aspect, of course, there is another technical sub aspect which is also important. So you can understand when you are actually traveling from aircraft and looking at the eclipse, very question come to your mind how you are going to record it. Okay, so when it comes to a recording, very important aspect is it's a small aircraft, or you can even face turbulence as aircraft is traveling. So major aspect one has to look is how you are going to capture a stabilized video. So we did, Space Geeks did a lot of technical review of coming up with a cheapest method of recording the eclipse, from in fact a mobile based platform, and then removing these vibrations which you experience from aircraft. Typically if your aircraft is small, you will experience more vibrations, and even if, let's say, even turbulence is bigger, even then bigger aircraft also you will experience these kind of vibrations. So what we did, we actually, using the software, we actually eliminated the vibrations. So what we did, instead of using a high-end technical device, using image processing and video processing platforms, we actually eliminated the vibration aspect. So you expect what you see post-processing is very stabilized view of the eclipse. In fact, on our YouTube channel, if you visit Space Geeks Mumbai, we have uploaded these videos. So so these kind of space technology projects offer you kind of exposure. You get opportunity to explore different aspects of space science and space technology. So that is why we have this platform called Space Geeks, where we have decided to create this kind of a talent pool through such technology projects and space science projects. So here you can see, in fact, we collaborated with one of the aircraft company which is quite well known in the aerospace industry, with the kind of ambulance service they provide, and they really took our idea and they supported us. So in future we will be in a position to take up such projects, as now we are capable to even do the calculations till an extent where we can simulate how aircraft will able to travel through a shadow. So I think that's I think my brief view about our previous event.
And these are some images and videos of, as you can see on the screen, of the eclipse captured from an aircraft, and the aircraft went up to around 20,000 feet. Okay.
So Ankush, will you talk something about space weather and eclipse connection, or how you look at eclipse as an opportunity to study space weather? I mean, in fact, all of us, we started with our very first scientific expedition with that motivation where Ankush was leading. So if Ankush can give us some idea about it.
Okay, I will be just brief, not in complete detail. So this actually eclipse already Virendra has explained. These are very unique opportunities. During that, we can see the sun's atmosphere, which we call solar corona, which is outer atmosphere, and that is very hot. It's the temperature is around million degree, and still that is more than 100-year-old problem unsolved. We don't understand why the corona is hot so much, because surface temperature of photosphere of the sun is around 6000 degrees Celsius, but the atmosphere is million degree temperature. How can you heat it? So this eclipse during only you can get such a nice detailed view of the sun, even spacecraft cannot provide. The very sun and the moon, apparent signs of the sun and moon is exactly almost similar. we can see inner corona to the outer corona, and we can do measurements. So that's a very unique opportunity only Eclipse can provide you, to take the scientific measurements and try to understand what is causing this heating of the sun's atmosphere, who is heating the atmosphere, like that you can understand. And that is one of the main uh, space weather implication of the eclipse. And even there are like atmospheric, already we talk, and they can affect your cosmic rays entry in the Earth's atmosphere, because sudden changes in atmospheric pressure and temperature can happen. And so whatever radiation coming from space can get modulated. Even that study can be done during such events. Yeah, I think that's enough from my side.
Thanks a lot.
Yeah, so it was great to have you all, dear participants, and we will look forward to come up with such topics. And now, since we are kind of facing this COVID-19 situation, so we will make sure that we will come up with lot of virtual sessions, and
Yeah.
we will tap virtual space, will be tapped by Space Geeks. And please follow us on our social media platforms, like our Facebook page, Instagram page, and Twitter. And please do give us feedback on our social media platforms.